It is now the next day. I have the chassis on this very green, bluish kind of towel, just so these screws don't scratch the bottom of the top of this desk. So I was looking around at this board a little more. This chassis is connected to circuit ground, so that's nice. But I was snooping around a bit and talk about overhead. Remember these 15-volt Zeners for our front end circuit? This here is a pair of 47 microfarad caps filtering for each rail. 16 volt. 15 volt Zener, 16 volt filter cap. Now, I was looking at these bulk filter caps, which come straight off the transformer, and this one here, the bottom of it is bulging. They're 25 volt rated. I would not be surprised if they're running at 25 or 24 volts. So what we're going to do is we're going to slide this up a bit. I'm going to stick the board on it temporarily, and we're going to connect this part of the transformer, which is our small secondary winding, I guess. So we're going to power it up, and we're going to see what voltage our filter runs at. So I'm going to grab my meter. I suggest I should plug it in, right? Our negative voltage is 20 volts. And of course our positive is the same. So these caps, there's 5 volts overhead. That's fine. I mean, I wouldn't design something like that, but it's fine. Nothing's going to blow up from it, right? So I'm going to replace those two caps because they're bulging. That just shorted out that capacitor. Circuit glue. Alright. The bottom of this guy is bulging. This one here. This one still looks good. What I have there is fresh out of my parts bin. These are some brand new Nijicon. These aren't the fancy caps. These are just the VR, which is, just general use. They're not low impedance, they're not audio grade, they're not high temp, they're just basic capacitors. These are 1000 mic 25 volt because, well, these are the highest I have. So, well, we're just going to install some new caps in here. There are our new filter caps in. New Nijicon VRs. Where my side cutters go? I'm going to keep these leads. How much do you guys want to bet that there is no thermal compound on these output transistors? Other than the fact that, oh, that's right, there's a nut on the back of these. I forgot about that. Where did my pliers go? They're underneath an amplifier board. It's stuck on there. Let's see. There is thermal compound, but it's very minimal. I am going to get some isopropyl alcohol and a rag, which I've also lost. Found it. I'm going to clean this transistor, this insulator, and we're going to put some new goop on it. What I'm going to do is I'm going to put a little bit of thermal compound on this plate, because you got to kind of mix it because the oil separates from it. Now the fun part begins. These things clean up easy because there ain't hardly anything on them. A little bit here. Stick it on the back of our transistor. Much better. And we'll stick our insulator to that. Oops. Ain't even pressed down yet. Then I'm going to get a little bit more and try to put it on the insulator. But I might have to put it on the heatsink, because if the insulator tries to slide around, which I don't think it is, so nope. Much better. Alright, I need to slide this chassis back around so I can get to the nut on the back of the heatsink. Okay. I cannot put this nut on with my fingers. Instead, I'm going to drop it. I need to hold this power transistor because it wants to spin around. And there we go. I think we got that. Much better. It looks a little nasty because it was spinning around. Now, there's 3 more to go. 10 minutes later, there we go. All, except this guy on the end, perfectly straight, new thermal compound in horribly unreliable autofocus. Okay, so I'm going to reinstall our amplifier board, but first I'm going to put back the connectors for our output transistors. Now, you can't get these mixed up because they've been in the same spot for 2 decades, so they've held their position. I wonder if this board is actually meant for TO220 outputs, because that's, happens to be the same footprint of these connectors. So they're connecting these external TO247. Alright, review out the way. And these plastic pegs, you just push it down. Get the one in the middle. Alright. This connector goes in there. This is our sub-winding for our front end. The main power. And our speakers. Now, since there's only one speaker, it doesn't really matter if you get them backwards. You're not like you're going to have phase issues, since it's a single-ended amplifier. I wonder what the voltamp rating of this transformer is. I could look up that number, but most times these transformer stickers are like in-house numbers, and they don't return anything. Other than maybe an eBay listing for that transformer, but there's no tech specs. It'll just say like the voltage. How do I want to do this? What I think I'm gonna do is I have the one speaker for this. There's two, but I have one because it uses the 1/4-inch plugs. But I think I'm just going to get my test speakers and solder the wires right on. Because why not? These cheap little Panasonic bookshelf speakers I have sound worlds better than the PA speakers that this thing has. Where did the amplifier board go? Oh, that's what. During the time lapse when I was doing the transistors, I heard a bang. And I didn't know what it was, but now I know. My test amplifier board fell off the back of my desk. Actually, you might have even seen it. It usually sits right there and it fell down. Actually, better, I'm not even going to bother to solder it because there's actually quick connects on this board, which are unused, and they have holes in them. Whew. The ultimate way of being lazy. Mainly because I don't want to wait on my iron to heat back up again. So watch how I'm going to do this. We got our signal wire. Now, I have somewhere right here. This is a breakout board. It's got a 3.5 on it and bare wire. Then I'm going to get our bare wire and I'm going to shove it into this. Now, I don't know what kind of gain that this board has. So I'm going to get my phone here, plug it in, and I'll turn the volume way down. Alright, moment of truth. Are we going to lose an eardrum? Nope, just good old power on pop. This board is just a normal line level input. See, this phone has a very low output. It's not even loud enough to drive a set of headphones. This is about the volume I would expect from it. That's disappointing. Right, so I've got the scope hooked up here. How I have this is I have my function generator here. I moved the line down because this will probably put out more output than this can show, because the screen only goes up so far. So I moved it down so we're only going to be able to see the positive rail clip. However, it's a split supply, so the top minus will probably clip at the same point. This way we can see the top of the waveform. I have it set to about 1 kilohertz. I have it turned all the way down. However, all the way down on this is not mute. I have it connected to 4 ohms if I haven't said that already. Alright, we're going to flip it on. And there we go. With this turned all the way down, we're getting 11.8 volts RMS. I can hear that transformer buzzing away. So let's go ahead and turn it up until it clips. Looks like it's beginning to clip there. Wow, yeah, that's where it clips at. Looks to be about 18.7 volts. 18.7 volts into 4 ohms comes up to 87 watts. Our heatsink is just slightly starting to get warm. Our dummy resistors are cooking. I got a thermometer here. How hot are our dummy resistors? They're about 170 degrees Fahrenheit. They're each 8 ohms, 50 watts. I have them in parallel. Let's go ahead and see what power this thing can do at light clipping. Maybe that'll give us close to a 10% rating that modern day manufacturers like to use. So let's go ahead and just say 20 volts. 20 volts into 4 ohms is 100 watts exactly. Alright, so I'm going to go ahead and call this a 90 watt amplifier since that sounds respectable. Now what? I know, I'm going to torture test this. What I'm going to do is I'm going to prop my dummy resistors up, and just for this reason, I have this DC computer fan. I'll set my resistors up, I'll plug this into my supply, I'll turn this all the way up, and it will just let it run at full power and see how hot the heatsink gets. Of course, I'll be monitoring it the whole time to make sure it doesn't overheat. Right, I've had it running at 90 watts for the past 10 minutes or so. Let's check out our temperatures. First, our dummy load, which has a fan directly attached to it. One resistor is reading 202 degrees, another is reading 190. I don't think it's attached to the heatsink very well. But it's got a fan running full speed on it. That's putting out some nice heat. Let's check our temps in our unit, right? The top of our transformer, about 95. I want to check our main bridge rectifier. This is for the amplifier. That rectifier is reading 182 on our filter caps. That's 98. It's 95. The big one, our heatsink is still touchable, but I'd rather not. Let's see, our outputs are sitting at. This one's sitting at 120. I don't think there's going to be much of a difference. 128. Let me try to. See, this thing's hard to use because the laser indicator is not where the receiver is. Let's check our PNP side. 130. What about this guy? About 127, but remember, this thing's not entirely accurate. About our emitter resistors. That guy's sitting at 111, 113, 120, 120 as well. Drivers, they're each sitting at about 96. I'm going to check my dummy load again. We're up to 217 degrees on the dummy load. This doesn't focus very well. You can barely see it. 217.5. Well, I guess I ought to get back to getting our boards back in for our front end. This is channel 1 and 2, which is the ones we use the most when we have the issue. Now, I'm debating if I want to plug them back in, just run this. You see, if I run this, I can actually use my phone, which has too low of a headphone out to do anything with, since, well, this thing's got enough gain to blow the roof of your house off. This is the signal out, I know that, which is this. This 4-pin thing here goes to the echo box, which I'm pretty sure we don't need to get this to run. Yep. And our supply goes here because it's the only other 3-pin connector there is. And of course, all the connectors are keyed, so they only go in one way, right? I need to drag the front because I don't remember which knobs are what. Ugh, this thing's greasy. This is equalizer, so we'll set that flat. Master volume. Everything's down. I set all the EQs flat. Plus minus 15 dB. At what frequencies? I don't know. There's only high and low. Let me show you the little contraption the club uses to get this to work. So how this works is we have a Radio Shack. This is just a normal 3.5mm patch cable. Okay, this goes into a stereo 1/4 inch, which then goes into a stereo mono 1/4 inch splitter, which then gets plugged into channel 1 and 2. I got my YouTube free music. Make sure again everything is turned out, because if this thing's turned all the way up, I'm gonna lose an eardrum. Look at that, there's actually enough gain to make this phone power something. Neato! Now I need to run it like this for, I guess, the next couple days, just to see if it cuts in and out again. Let's play with our bass controls. Oh, nope, that's highs. There's one mid, but it's only on the master, which is up here. Ouch. And now we play the waiting game. I've had this thing apart for, oh, I don't know, 5 or 6 days now. I'm just going to put this thing back together because I'm not finding any issues with it. It's not acting up at all like it used to. I mean, none of these controls are even dirty. Which is the part I don't get. So, I'm going to assume that it's fixed and ready to go since it's not acting up in any way at all whatsoever. So, yeah, what I'm going to do is we're going to start, we're going to disconnect these front boards, the cables, right? Then we're going to snap this back assembly back into the cabinet. My thought is to, well, you can't really see, but my thought is to get the chassis and kind of like drop it in. Alright, that's a better angle. I lifted my tripod up. The camera's about 2 feet from the desk now. Yeah, I'm just going to try to drop this thing back in. Now, remember, here's this clip. This clip got stuck in the chassis right here. Let's see if I can slide it back in. Okay. It's not going as smoothly as I planned. Alright, I bet that just shook the camera all up. That looks good. And that looks good. Actually, no, not quite yet. I should screw it back in. I don't remember which screws went in the back. Well, I think it's these short black ones. Alright, so how did this come apart? Actually, no, I'm going to clean this before I put it back together. Something that's good to clean metals, good old basic house Windex. Spread a little bit on there. Then, there you go, wipe all the gunk off of it. Ooh, it's a lot shinier now. Alright. Ugh. So, it goes together fairly simple. Just pop it back in here, same way it came out. Although getting all these potentiometer stems aligned will be the issue. Oh. Aha. Almost. Yes. Okay. Stick these nuts and washers on here. I'm going to get the other board in. Alright, all those are back on. When I was putting this together, I noticed something, and I'm pretty sure this is actually a typo in the print that's on here. Check this out. Here, where it's labeled microphone, which is not where we use the mic, there's words under it that says, I assume that's supposed to be play. Since this is record, I'm pretty sure this means play. And they got the A and the L swapped. Okay, so now that all those screws are back in, this whole front piece is secured. Now we're going to reattach our two jumper wires here. And again, these things, you can't get them backwards because they've been in the same position for so long, they've all held their shape. This is our DC supply, which I shouldn't have unplugged because that's going to be kind of difficult to get it replugged in. Actually, no. I just need to see where the connector is. I love single-sided boards. You can just see your supply, how it just flows across through all these jumper links. Oh, yep, and we our audio signal. Might not want to forget that. Make sure I ain't forgot anything. Nope. All is good. I'm gonna check these RCAs at the end of this reverb box just to make sure they're in there tight, which they are. Okay. That was easy. I wish it came out that easily. Let me readjust our camera here since we've moved out of shot. Now we're back at this angle. Same thing. Grab our screws. Yep. I have not lost any screws yet. I'm surprised in that. Every screw has went back in where it's supposed to. Also, this front panel is only held in with 2 of them. I guess now we'll go back to another time lapse of me sticking all these knobs back on. Won't be too hard. I got them all in a box right up here. Well, I'm not going to need the Tessa tape. So let's begin. Alright, so there's all our knobs back in. I'm just going through an OCD and turning everything, all the gains down, the reverb down, and all the EQs flat. Then we'll, guess we'll plug the phone into it, play some no copyright tunes, and see how it works. Actually, no, I won't be able to do that because I can't access the speaker terminals on the back. So I can't use my test speakers. I guess I could pull out the speakers that goes with it, but I don't want to. No, I'm not going to do that. Watch what I'm going to do. Here is our speaker wire. It's 16 gauge on these 1/4 inch plugs. These are the kinds that you put together, right? So you just screw it apart, nice and soldered together. My bad, no, it's 18 gauge, not 16. Alright, what we're going to do is we're going to plug our one speaker wire into it. Then I'm going to pull out these guys, some alligator clips. I'm going to clip onto this so I can use my test speakers on it. Because the speakers that come with this thing, which are the matching set, they sound horrible. Like, I have not heard a worse speaker in my life. Make sure those don't short because I'm pretty sure with a 15 amp fuse, if it shorts, it's going to take the output stage out. Right, so this phone's all the way up. However, the output is so low, we're going to turn our gain about halfway up, and now master volume. And there we go. Let's see how good our reverb works. Turn this up a bit so the camera will hear it. I don't hear any difference. That's the master reverb. Let's try the reverb on each channel. I don't think the reverb works. Oh, now I got it. Gotta have them all up. Yeah, you can hear it through that spring. That's kind of cool. It's kind of like tube preamps. If you knock on them, you hear the plates rattling around. Alright, and just to be safe, we're going to go ahead and check channel 3 and 4. However, we only use 3, but oh well. Oop. Gain. Yep. Same thing. We'll see if our reverb works. which it does. Tone controls. Tone controls all good. And as a bonus, let's do the never used once 5 and 6. Turn those gains back down. 5 and 6 up. Check reverb. Reverb's good. That's the wrong knob. No, it's not.
What you saying? Bitch, I'm over you and I ain't playing. Should've been a one night stand.
Drop off.
You can check out the iPhone.
Okay, I think that's enough of that for now. Right. It works perfectly. There's not a thing wrong with it. That's that issue we was having when we were using it, where it completely fades out, you bang on it, comes back. I don't know what caused that. I deoxidized the controls, hit up a bunch of solder joints, replaced some caps on the amp, and I'm sure that's not the problem, but they were bulging and I didn't like it. So, well, I guess I'm going to call this excessively way too long project done. So, you guys already know the drill. If you liked the video, feel free to leave a like, subscribe, maybe leave a comment, and I'll catch you guys in my next video. Bye for now.